In this video, I'm going to solve this question. For those of you who have tried solving this question on your own, let me tell you right up front that there is some issue with this question. So basically in this question, they have given us some information related to these three probabilities, and they are asking us to find the probability of A complement intersection B complement union C. Well, if you try to find this probability given the information that we have in the question, the right answer is going to be 0.28, which is not matching with any of the options given over here. Okay, now because there are issues the way this question is written, so I'm going to rewrite this question again, and I will not focus on these options that are given over here. In this part, we have to figure out the probability of A complement intersection B complement union C. Okay, so first of all, instead of writing A complement intersection B complement, I'm going to write Q. Okay, so I'm simplifying the notation. Instead of writing this again and again, A complement intersection B complement, I'm going to write Q, as this would make the notations easier. So this implies that I have to figure out the probability of Q union C. Okay, which we know is equal to probability of Q plus probability of C minus probability of Q intersection C, right? So from here, I'm writing this, and then we know the formula, which is this. Now from these three terms, I already know probability of C. Okay, so this is something that we already know. So ideally, we just have to figure out this probability of Q and the probability of Q intersection C. Once we have these two terms, we'll have the answer to the second part. So first, let's try to figure out the probability of Q. Okay. So probability of Q is actually equal to the probability of A complement intersection B complement. Now, if you know your properties well, then you should know that this can be written as probability of A union B complement, which further can be written as 1 minus probability of A union B. If you are wondering that how are we going from here to here, then let me quickly make a Venn diagram and show you that this is actually going to be equal to this. Okay. So let me draw two circles over here. Let's say this is for A and this white one is for B. Okay. I'm not going to draw C over here as C has no role right now. So this is A and this is B. And once again, the way I have drawn it, there is some intersection between these two. Now we have to find probability of A complement intersection B complement. So let's try to shade the region. So A complement is going to be this entire region, that is not A. So this. So this entire pink region that I am shading, this is your A complement. Okay. So this entire thing is A complement. Right. Now let's try to figure out B complement. So the B complement is going to be everything that is not B. So it is going to be this. Okay. So we don't have to shade B. Now note that in this question, we have to figure out the probability of A complement intersection B complement. If you talk about A complement union B complement, then it would become the entire sample space. That is something that we discussed in part number 1. Over here, we are working with A complement intersection B complement. That means we have to look for that area where we have the pink as well as the white. So basically, if you see, then apart from this region, okay, so apart from, let me shade this region over here. So apart from this yellow region that I'm going to shade, so there is no pink and white intersection in this region. Okay, apart from this region, everywhere there is pink and white intersection, but there is no pink and white intersection over here. So this yellow shaded region or orange shaded region that I have over here, this is the only region from the sample space which is not included in the intersection of pink region and the white region. Okay, and this orange thing that I have over here, this is actually A union B. Okay, so A complement intersection B complement includes everything but A union B. That means this is just A union B complement. Okay, and this is why I have written this. So now let's figure out what is this probability of A union B. The probability of A union B, as we know the formula, it is probability of A plus probability of B minus probability of A intersection B. So probability of A is 0.5, probability of B is 0.6. We are not given the probability of A intersection B directly, but they have given us that A, B and C are independent events. That means probability of A intersection B is equal to probability of A multiplied by probability of B, which is equal to 0.5 multiplied by 0.6, and this is 0.3. Okay, so probability of A intersection B is 0.3. That means probability of A union B is 1.1 minus 0.3, so this is 0.8. And over here, the probability of Q is 1 minus probability of A union B. That means this is 1 minus 0.8. So this is 0.2. Okay. Now, when we started this question, I told you we have to figure out three things: probability of Q, probability of C, and probability of Q intersection C. Probability of C is already given, so this is sorted. Probability of Q is something that we just got. It is equal to 0.2. Now, the last thing that we have to figure out is what is the probability of Q intersection C. Now, let's see how can we figure out the probability of Q intersection C. And once again, let's first visualize this using Venn diagram. So over here, I'm going to draw three circles. This is A, this is B, and this is C. Okay. Now Q is A complement intersection B complement. And we have already seen that A complement intersection B complement is actually all the area that is not A union B. So A complement intersection B complement is actually this entire blue area that I'm shading. Okay, so this blue area is A complement intersection B complement. Okay, so this entire blue area that I have shaded, this is A complement intersection B complement, that is, this is Q. And we have to take its intersection with C. So the intersection with C would mean that we will get this region. Okay, this red region that I'm shading over here, this is the intersection of Q and C. So this over here. Okay, so this is your Q intersection C, and we have to figure out the probability of this region. Now from here, it's quite simple to figure out what is the probability of Q intersection C going to be. So from C, we have to subtract the probability of A intersection C, and then we have to subtract the probability of B intersection C, and then we have to add the probability of A intersection B intersection C. So C is your entire red circle. From this red circle, we are first subtracting this. This region is your A intersection C. I'm not shading the entire region, I'm just creating the outline. So this green outline that I have created, this is for A intersection C. Similarly, I can create an outline for B intersection C. This blue outline that I'm creating over here. Okay, this is for B intersection C, this blue outline. And when you subtract A intersection C and B intersection C, that would mean that you are subtracting this tiny area. Okay, this orange area that I'm shading in between, you're subtracting this twice. So you have to add it back once. And this orange area is A intersection B intersection C. So from C, subtract this and add this, because this was subtracted twice. And now all we have to do is that we have to figure out that what are the numbers that we have on the right hand side. Okay, so this is the last thing that we have to do. We have to figure out probability of Q intersection C. So this is equal to probability of C, which is what we are already given in the question. It is 0.1. So this is 0.1 minus probability of A intersection C. Because A, B and C are independent events, we can write that probability of A intersection C is equal to probability of A multiplied by probability of C. So this is 0.5 multiplied by 0.1. So this is 0.05. So this is 0.05. Similarly, we can figure out the probability of B intersection C. Probability of B intersection C is going to be probability of B multiplied by probability of C. Probability of B is 0.6. and probability of C is 0.1. So this is 0.06. So this is minus 0.06. Similarly, we can figure out the probability of A intersection B intersection C. Note that in the question we are given that A, B and C are independent events. I'm assuming that they are mutually independent events. When the events are mutually independent, that means we can write probability of A intersection B intersection C as probability of A multiplied by probability of B multiplied by probability of C. Okay, so if we take A, B and C to be mutually independent, we can also write this, and from here we can see that this probability is equal to 0.5 multiplied by 0.6 multiplied by 0.1, and this is going to be 0.03. Okay, so we have to add 0.03, and this is equal to 0.02. So the probability of Q intersection C is 0.02, and now we have all the information that we need. So the probability of this thing that we have to find, that is Q union C, is equal to probability of Q, which is 0.2, plus probability of C, which is 0.1, minus probability of Q intersection C, which is 0.02. Okay, so this is equal to 0.3 minus 0.02, and this is equal to 0.28, which is the final answer. So that's it for this question.